is Marni. I put my note cards over here and forgot about them. Cool. Business system developer at Puppet, formerly known as Puppet Labs. It's a server automation company. We work on a smaller team of 4 folks. I started as an intern learning Ruby, moved into Elixir full-time about a year ago in August. By daytime, I do functional programming in Elixir. At nighttime, I switch to C# and make video games.
And I'm Gabriella. We work on the same team together. If we switch off a lot, is this going to be bad for our microphones?
We just have to avoid each other.
I've been programming professionally for about 2 years, I guess, if TAing for intro students counts for a bit of that. And I spent a portion of that time learning Ruby and unlearning the functional paradigm that I'd been taught in school, and then the rest of the time since then, unlearning Ruby and relearning functional programming with Elixir.
And that's our team. That's totally what we look like in the real world, as you can tell. There's me and Gabriella. There's also Jeff Weiss, who was, as Robert would say, our prophet. He made us drink the Elixir. And then Manny, who's newer to the team, who has a Java background. And what our team does is we build internal tools for the business. So if someone needs something automated, if they need data pulled from Jira or something, we figure out how to make that happen. So we have a lot of freedom in what tools we use. And the tool we ended up going with is Elixir. And this book was basically all of our introductions to Elixir at different times. I think that Jeff and Manny both read this book when it was still in beta, and then we signed on a little later on. I remember I was reading this and the book is called Programming Elixir. Also, I should say things out loud. I remember I was in a coffee shop working from home one day, and I was reading this book, and it was my first introduction to functional programming at all. And I was so surprised. I was just like, pattern matching, pipe command, like what is going on? And my friend, who is not technical, was in the same coffee shop, and he was just like, what? Why are you gasping out loud at this programming book? What's going on? I was like, oh, you know, it's just like this is all so different and new. And he was like, oh, can you explain it to me? And I was like, well, first I'd have to explain object-oriented programming and then tell you to forget everything and turn it upside down, and that what you've been reading has been backwards this whole time. And I lost him right about there.
This talk is going to be a survey of some of the lessons that we've learned while moving our team from Ruby to Elixir over the last year. And so we're going to sort of dive into that using 2 rewrites as our main focus. So one is a rewrite of a company directory system, moving from Ruby to Phoenix, and another, the second one, which I'll take, is the data warehouse that we're currently working on.
Cool. So I'll start with the internal directory. This is Robbie. Robbie's main focus is to be an internal website where you can see a map of the office and see, oh, HR sits on the 5th floor over here. Or, oh, there's a new hire, what's their name? Like, Sarah, what does Sarah look like? Type her name in, see a photo, have an idea. Really important, especially for a fast-growing company, to know who these people around you actually are. It was my first Ruby project, and I was really excited, and I had very little supervision, so it turned into a mess really fast. It was a single-page app, purely because single-page websites were really hip at the time, and I didn't know how to make good decisions, so I was like, oh, this is a cool thing, I'll just try and do a cool thing. And it was a single file, the main app was a single file of 937 lines of code, and it was disgusting. I mean, it would fail, we had a little, our operations team had a file that would kick it, or an automated tool that would kick it every hour to restart it, because it failed so often. And it was just messy from the ground up, and it reflected how, I didn't know what was going on. Other people who touched the code would mess with things, and I wouldn't know what they did. I didn't know how to read Ruby very well, partly because I was a new programmer, and partly because I was writing messy code in the first place. Here's some beautiful examples. I went back and looked, and my comments are just like, I don't know what this does. I still am not really sure. And I mean, it was 2 years ago, too, so that doesn't help. Not sure if I could take that out and if nothing would break or if the whole thing would go down. tried to look it up recently, and I still am not sure. And me trying to figure out how to make something secure, but I didn't understand how salt worked, and I'm adding salt on top of a password that already has salt on it, and chomping, it's gross. You can see how gross it is. But I was proud of it, because it was my first app, and it worked sometimes. And not enough, clearly.
That was a joke.
Yeah, was that a joke? It didn't work ever, apparently. New hires would be told, oh, welcome to this tool, Robbie. Here's a way to meet your coworkers. Here, just update your picture. And they wouldn't be able to update their picture. It would break. They sometimes wouldn't be able to log in. I don't think you could.
When I was hired, I couldn't put my info in.
Yeah, it was like, welcome to Puppet. Here's a broken tool to meet everyone with.
But the logo is very cool.
Yeah, but the logo looked great. It was cute. Everyone loves a friendly robot and a single-page app. So I was proud, but I got pushed to other projects over time. Other teams picked up Robbie, added a bunch of JavaScript on top to make up for what Ruby couldn't handle and what I couldn't handle to put in. And it got harder and harder for me to go back and edit the code or participate in this thing that I had built. So we decided eventually to rewrite Robbie in Elixir, just like burn the whole thing to the ground. Still have the old repo somewhere. It's good for a couple of laughs. And so we started with Phoenix, and Phoenix was awesome. I mean, we use it in Hack Day projects. We use it for rapid prototyping. It's been really amazing and nice, and it sets everything up sort of in a pre-structured way, so I can't put everything in one file like I could with the first Robbie. And the original Ruby Robbie, just as background, was basically talk to a database LDAP, Lightweight Directory Access Protocol, pull that into Ruby, push that to Sinatra, and then wrapped it all in JavaScript, but with too much duct tape, basically. It wasn't like a neat little package. It was gross. So without all that JavaScript on top, with Phoenix and Elixir, it was just so much faster because we can make the requests on the client side. I didn't have to use Ajax with Ruby, which if you're new to programming, trying to learn Ajax is like throwing someone in the deep end. It was a lot scarier than this. I wish I had started here. But then I wouldn't know how good I had it, I guess. And a couple of things that made it better was umbrella apps. So making it easy to go in and out. So we had Robbie Web, where you could edit the templates, the views, all of that. SMS codes, so if someone forgot their password, we could go here and be like, okay, this is how texting the information goes. If we wanted to text all of the users in Robbie to troll them or something, this is the code that we would look at. If we wanted to write or read to LDAP, there were different directories for that. And then we had a LDAP wrapper so that if we change our backend, if we don't use LDAP anymore to store our employee information, we could sub out LDAP read and write, and the wrapper would still function as an in-between with little editing to make it work. So this makes it so much less intimidating to go in and fix and change things and add to it, rather than going through this nearly 1,000-line file with all those disgusting comments and code that I couldn't read. This just simplified everything significantly for me. And then we even got to have some fun. We added a guessing game where it pulls pictures of employees. I censored everyone's last name because that seemed like what I was supposed to do, even though I don't think you can read that from here anyways. And it's an easy way for new people and folks who have been there for a while, or remote employees especially, to guess who. Like, you see a picture, you have a bunch of names. There's some bonus rounds where if there's a really common name, such as like Nick or something, you can see all of the Nicks, and you have to guess which Nick is this one picture, just as an extra hard mode. And we have a little high score, and the scores are all kept with Ecto as individual gameplays, so you can pull the stats really easily about it. And it just handles the user, the choice, and the right option, with a couple of other features, such as request a better picture. Like, my picture in Robbie is a cat. So I get emailed constantly from this little button that we implemented saying, hey, I don't know who you are, can you have a better photo? But since I made the tool, I break my own rules. So it's for everyone else, it's not for me. And it also handles no choice. So if you try and just hit the next button without picking someone, you know, it knows what's up. It's not as dumb as most computers. And we also had some fun. So we use HipChat a lot, and sometimes HipChat goes down. So as an exercise in how to use channels, we built a little chat room inside Robbie. So sometimes when HipChat is down, you can go in, and at first we didn't scrub out HTML and stuff, so people went a little crazy with that. Wish I had screenshots of it. They're just like cat pictures. Yeah, putting marquees in it, and then it got a little more hazardous over time, so we had to update that pretty quickly.
Just as a testament to how easy these things are to spin up, though, like this happened in an hour and a half. I think one day when the whole company was just grumbling about how impossible it was to communicate. So, quick and easy.
Yeah, no, it's been really awesome, and it's a tool that everyone knows. And for April Fools, I changed everyone's picture to the CEO's face because it was just so easy to edit, and it's a great site for pranking. And our company is pretty pro pranking, like moderately. Luckily, the CEO has a good sense of humor, so I still work at Puppet. I don't know how I'm going to top this one, though. I mean, it's so good. But I had the confidence to go in and edit Robbie without thinking that I was going to break everything. Because it's kind of scary to be like, oh, I'm going to change everyone in the company's photo to this and hope that at the end of the day I can change it back. And it was fine. Everyone doesn't look like this anymore, except for the CEO. He still looks like that. And overall, we packaged it with Jenkins. We deploy it with Puppet, good old Puppet, behind a VPN because we have to keep the data, sensitive data. It's private, so we can't use Heroku or something like that. And it's been really successful. We don't have to restart it hourly. It's easy to update. I can touch the code again. Like I can use my own project and update it. It isn't abandoned. It isn't run away. Like it's ours. It's real and it's still in use. And new employees aren't set up to fail anymore. They're like, oh, here's a tool, and it actually works, which in technology, like maybe half of the tools work ever, I feel like. So it's a relief to be on this side of it. And I mean, using Elixir, especially coming from Ruby, it prevented me from falling for programming mistakes that I fell when learning Ruby. Because the architecture and philosophy of the code encourages good programming habits. And that reflected on our team and how the team approached problems too. Like we broke it down easily. It was easy for us all to have interchangeable parts. It was easy for us to own different parts while understanding what each other's sections all did and be able to comfortably edit those as well.
Okay, so after our first big Phoenix project, now our main application that we're working on in our team is a data warehouse. So this data warehouse is an application that collects, sorts, integrates, and stores. I can go to the, yes. Integrates and stores data from all sorts of different tools and services we use across the company. So sales data, customer service data, what little telemetry data we have. And it's a platform for analysts and business intelligence tools to use. So this is another rewrite, and I wanted to talk a little bit about the former application, just to give you a little stark contrast for our Elixir project. So this is our current data warehouse. It was written in the space of 5 weeks after somebody's split-second decision not to renew a contract with an external data service. So very small time crunch to get this whole application off the ground. And because of that, a full data load of all our different sources would take 8 hours from start to finish, which is ridiculous. So we couldn't do this more than once a day. We couldn't do this more than once a week. And so we had to do incremental refreshes all the time to made our architecture even more complicated. So the reason that it took so long is because the main task logic was in one giant Ruby script that was 300 lines long, and we'd have cron jobs managed by Puppet, which, by the way, is not a good Puppet practice. to kick off this script every once in a while. And there was a little bit of concurrency. We used JRuby, which also caused other problems, right? So if you want to use JRuby, you can't use a lot of gems that just aren't compatible at all. Right, so in this script, we would load one data source after another, and this caused all sorts of problems with dependencies that were completely unnecessary. So if we have a problem, say a change in the data contract of the sales data API that doesn't, without notifying us, and that bit crashes, then the rest of the data doesn't even load. We don't even get to the customer service data. And for a business data application, this is silly, right? This is a problem. We don't want the success of one data load to be dependent on the success of one that's completely independent from it. So basically, this application is full of terrible anti-patterns, spaghetti code, unneeded dependencies, but it's also understandable, right? Because in our time constraints, the mental and emotional energy required to implement concurrency in Ruby, 5 weeks is just not enough. So needless to say, whenever we wanted to change something, add a feature, add a couple fields, the whole thing would, and running on a single server, forgot to add, the whole thing would go up in flames. So we were very pleased and relieved to let go of this horrible application that we've been depending on, limping along on for the last 2 years. And to call this a rewrite, this is our Elixir gap, right? To call this a rewrite would really be an understatement of the incredible improvements that were enabled by Elixir in terms of segmenting failure and sort of increasing the reliability of our system. So in the same amount of time, less even, this is 4 weeks, same amount of developers to people working on it, we were able to prototype a system covering all the same bases as our last application. And we decreased our load time to 45 minutes. And this is the time it takes to load the largest object that we have in Salesforce, which is 60% of our data in Salesforce. How did we do this? We did it with Elixir and OTP, of course. So utilizing the supervisor structure and making gen server processes for the sort of smallest independent chunks of work that we could manage. So we end up now with 4 or 5 data sources. We're eventually going to have around 50. We have 1,300 processes instead, which I guess according to Robert is not very interesting. But it's interesting to me, right? I'm used to single-threaded code. So in this way, we're able to staunch the flow of failure at the lowest level. So if one data source fails for any reason, or even one object in that data source fails, we can try that a couple times or kill it altogether and let the rest of the data load happen unaffected. And also an added side effect bonus is that because of the way we've structured our application using message queue architecture, we can now throw our application up on as many servers as we want, 4 or 5, and in that way horizontally scale without any extra work at all, because we have the instances on each server just listening to the same central message server. Whew, that was a lot. Okay, so this has been a really fun project, and I've learned a lot about the sort of nitty-gritty of Elixir and OTP, and I wanted to share a couple lessons that I've learned and problems that we've run into and solutions that our team has generated. 5. That's the number of servers that's up on the screen currently. We forgot to warn also in the beginning about motion sickness. There's a lot of zooming in this presentation, so if you get woozy at all, just like put your head between your legs and take a couple breaths. Robert touched on this a bit. The first lesson that I wanted to share is that Elixir processes are not Ruby objects and should not be treated as such. And so you might take pause at this because you hear a lot that processes and gen server is Elixir's answer to state, right? This is how we can do non-trivial things with our programs. Otherwise, we'd just be sitting around and doing a bunch of math problems. But while it's a well-warranted analogy, it's dangerous, and that's because the environment that we're working in is different. So if you take an object or something you can treat like an object and put it in a concurrent environment, all of a sudden you've opened yourself up to all sorts of dangers and pitfalls. So what does it mean to treat a process like an object? We'll take a look at one. So this is a process taken from the data warehouse application. It's the extract worker, so it's responsible for pulling data from some external service. And when our application starts, the process is just there, sitting on the beam, until it receives a message that says, hey, it's time for you to do some work. So then what our extract worker does is it calls out to the external API, gets the data, and stores it in its state. Now, this is what I'm doing as a Ruby programmer. We're going to change this process in a second. So extract worker has the data in its state, and some other process somewhere else in our application is alerted to this fact. This is the insert worker that's responsible for doing some stuff to the data and putting it away. So it makes it's also a process, a gen server. It makes a gen server call to the extract worker. Extract worker is like, oh yeah, I have that data, here you go, you take it. And then the insert worker does some stuff with it, right, transforms it, and then sends it off to the database. Okay, so this was my first instinct as a Ruby programmer, right? That my extract worker is sort of analogous to what I had in our original Ruby application, where I have an extractor class that I initialize with the data, and then later on in my program can access, edit, do whatever to. But in this environment, we run into some problems, and we open ourselves up to unwanted side effects. So right now, the problem here is that we have functions inside our insert worker that are impure because they're making a gen server call out and using shared state, basically treating extract worker like shared global state. We have functions that depend not only on their input, but also the state of an external process. And this is bad news for functional programming. It's bad for testing. It leads to all sorts of complex structures that we just don't want to reason about. So if you see this in your code, you kind of need to take a step back and try to instead implement something more like a data flow. So this would be a more optimal way of implementing that, where instead our extract worker just receives a message. When it does its work, it sends the entire chunk of data to the insert worker, which does its work. And trade-off here is that the extract worker needs to know about all of the recipients of its data. It needs to know who to send it to. So everything's great, good, not quite. There's another problem with this picture, and that is, what if our extract worker just goes up in flames in the middle of doing its work before it's able to send the data on? So say the server request times out. Well, as Robert was saying, we don't really have to worry about failures, right? This is Elixir, that's Erlang, this is OTP. Our worker is part of a supervision tree, right? So when it is kicked, it'll just get restarted by the server. In fact, I have a little quote taken from the Elixir Lang front page website. To cope with failures, Elixir provides supervisors which describe how to restart parts of your system when things go awry, going back to a known initial state that is guaranteed to work. And this is where we run into our second problem. See, the insert worker is not going to be useful to us if we restart it in its initial state. So what we want is not only our Gen server to be restarted, we want it to be restarted with the work that it's supposed to do. Because if we kick it and it gets booted up again by the supervisor, it's just sitting there. It's lost that message that it received. And we don't want to lose that data load, right? We don't want to lose that run. So turns out that supervisors are not a cure-all. And sometimes we need to extend our thinking about failure a bit beyond them. Okay, I've lost track. I've gotten ahead of my note cards.
You need some water?
Yeah. Do I sound...
No, you're good. And the solution that she's about to talk about does get solved in the future, as we learned at Orlando ElixirConf, but...
Yeah, so what we need in this case is a pub sub, right? We need some sort of message queue where we can send and receive messages between our processes in a durable manner, right? So if a message doesn't get delivered, it's not lost. And with Phoenix pub sub and potentially some assurances in Gen stage with Flow, as we heard about in Chris McCord's keynote and also Jose's keynote in Orlando, might happen in the future, or will happen in the future. But until then, yeah, we have an interim solution using RabbitMQ and a message queue architecture. So I'll explain this a little bit. So this is a similar picture to what I had before, but expanded a little bit. That triangle, that first triangle, is an exchange. So we'll have an exchange for each of our data sources, and then each object within that data source is going to subscribe to its own queue that's bound to that exchange. So when a message comes in that says, hey, it's time to do that work, then it fans out to all of those queues and then consumed by our extract workers, which are now subscribers to this message queue. And when they have finished doing their extractions, they will send the data in packets up, in this case, to another exchange, because for each object we want to do several different things with that object. So we'll have different workers subscribed to the exchange for each object within a data source. So a little more complex than it has to be. But right now this picture looks a lot like what we had before, but just more complicated, right? What benefit does this give us? And the key here is that we want durable queues. So it's this last line in here that is what is really important. AMQP is the library that we're using to interact with RabbitMQ. So this noac set to false, which is really the same as ACK set to true, requires us to explicitly acknowledge that we have received the message to RabbitMQ. So at the end of all of the work that the insert worker is doing, after it's sent its data back onto a different queue, then we acknowledge that we've received the message and the message gets deleted from the queue. If, on the other hand, the insert worker dies, then its connection to the message queue dies and that message gets sent back onto the queue and is received again when the worker is restarted. Cool. So this is, if you're interested at all in RabbitMQ, there are great tutorials on their website, and there are actually code examples up in Elixir for AMQP provided by Jeff Weiss, who was on our team. Yeah. Oh, that's too quick. And so I have one more thing that I wanted to talk to you about that sort of touches on the multilingual section of Robert's talk. And so we are building a data integration platform, right? Its main function is to go and talk to the rest of the world and get a lot of data from it. The problem is that the rest of the world speaks Ruby, not Elixir. So there is a huge ecosystem of gems for interacting with and accessing thousands and thousands of REST APIs. And I'm wondering now that we've decided, we've made this decision, we have our prototype up and running, everything's great, we have 4 data sources going. I'm wondering if we've just condemned ourselves to writing client libraries for every data source that we want to access using Elixir. And the answer is, let me get to the answer here. Not necessarily. So, of course, like we do want to contribute to the Elixir ecosystem. So sometimes you just bite the bullet and write the library. And when you do, you realize it's not as bad as you thought it might be. So these are just a few that we've written on our team. ForceX is for interacting with Salesforce. Greenhouse is a recruiting software. Ecto LDAP is an Ecto adapter for LDAP. If anyone else in the world needs to use that, you can find it, talk to us. And Xtact is for Intact, which is an finance and accounting software. And so it's not so bad. I heard, I was talking to Jeff Weiss, who wrote ForceX, and he sat down and in about 2 hours of coding, he had said he had gotten about 90% of the functionality that he used of the RubyGem database.com, which is not too bad, right? So, but we don't have time to do it for everything, right? Like we have clients, we have customers, we have deadlines, and we need to get our job done. And like, yeah, 50 more data sources to do this for. So we can't spend all day writing Elixir libraries. So in order to use Elixir in production and still get our jobs done, we've exported some of that work into Ruby. So, oh no, my code is not there.
Do it again. Yeah, I'll show.
Oh, there it is. Okay. Well, I had that so it doesn't distract you. Now I remember. Right. So this sort of interim, like very naive solution that we have that allows some of our subcomponents to shell out to the host system and execute Ruby, or you could use Python, whatever other code you have, through our OTP supervision tree. So the reasons for doing this, we already have decent Ruby code that does this from our last application, right? It wasn't the code for talking to the customer service portal itself that was the issue. It was how all of those components were strung together. So now that we have a sort of task skeleton in Elixir, which is the strong point, we can sort of recycle that code, which wasn't so bad in the first place. And we also have other people who want to contribute to our code base, to our project, who aren't Elixir programmers. Their main language is Ruby, and we want them to be able to add to our system and write subcomponents in their language of choice that can just hook in as they wish. So we have devised a shell worker, we call it, that is really fairly naive. You could use messaging for this as well, but we've decided to just trust that those other programmers know what they're doing. Not a good idea. So my worker now is going to look like all of the rest of them. It's still going to subscribe to a message queue, and then when it's done, send a finished message off to another message queue. But when it's time to do the work, this is quickly becoming my favorite Elixir function. It calls system.cmd with a command that the Gen server was started with. And you can pass it environment to, in this case, it's the database that we're connecting to. And we just assume that if the command exits with a 0 code, then everything went as planned, and we can acknowledge that we've received our message, the AMQP ACK. And otherwise, we either try to redeliver the message or reject it completely if we've failed too many times. And so, yeah, in this case, our command is do some stuff in Ruby, but it doesn't always have to be the case. You can do whatever. And this is just a sort of a simple example to show that it's possible and not sort of out of reach to hook languages into one another. And this is sort of the simplest solution that we could imagine. Okay, I think that's just about does it. Those are the 3 lessons. Respect your roots. What were the other 2?
Switching to Elixir has helped us streamline a lot of what we've done in the past without having to abandon everything that we were doing before Elixir. learning it all on a team has been really great because we've all been kind of on the same page, even if someone is more advanced, like paired programming has still really helped all of us with learning Elixir, with building each other up. Our applications crash way less, which is a good thing. Yeah, and overall, Elixir and Phoenix have been like really awesome to work with.
Excited for the future.
Yeah.
Also, I know this conference is about Elixir in production, so if you wanted to hear a little more about that pipeline that we have for rolling out our own Elixir releases, you can talk to either one of us, or also there's a few Medium articles also by Jeff Weiss that sort of explain in a nice how-to that system that'll get you on your feet. So if you want to get your application like out there in the world so other people can use it.
Yeah, okay. I'm not sure if we have time for questions or if you just want to find us afterwards. Oh,
really?
Great. Even better. It's a good sign, right?
Okay, yeah, please do. We should have our contact info up here. I'm Gabriella at puppet.com if anyone wants to reach out about anything.
Marni at Puppet.
Hello? Yeah, okay. Thanks for that. What are some challenges that you found in terms of getting these things into production, deploying these things? Because I think that's an area that's still quite challenging in many ways. So I'm interested to see what you sort of did in that.
I mean, one of the good things is that everything that we deploy is internal, so I think that's made it a lot easier for us. And we have an Elixir fanatic on our operations team, so we have some sympathy there. I don't know if you want to talk.
Yeah, right now we're using a combination of EXRM and Conform, which are, I don't know how to say his last name, Paul Schoenfelder. Someone help me out there? No? Okay, those are his libraries that I think are going to be replaced fairly soon with a new one that he is working on. So Conform, it helps with production configuration, so allowing you to change and set that separately from packaging your release together. And EXRM makes ODP releases, so that has Erlang and everything you need to run the beam all packaged up into your release. And then, so I'm just sort of like going through our pipeline. It sure use a lot of trial and error to get there, but right now I just have the end in mind. And we're hosting on Debian machines, so we use the FPM, which is a Ruby gem, actually. It stands for fucking package manager, because it just gets the thing done. And it makes Debian packages, which we then hand off to our ops team, and they deal with making that repo available to our Puppet code, which we have on our production machines, and that just makes sure that we have the most current version of our software running on that machine. Does that sort of, I mean, that was just an overview. It didn't exactly
That was great,
struggles.
thank you. Yeah,
Okay.
thanks.
Thank you.